All right, I'm just going to kind of start off and reiterate where we were last time. Ooh, it's fancy. Oh, that sucks. It's on the other screen. Whatever. Okay, so I'm leading the chassis team. That's Abel. This is the last time I saw the chassis, pretty much. I mean, I saw it when we went back to the shop, Abel, that one time, but I didn't take a
Yeah.
good look at it. I'm pretty sure we're going there this weekend, so I'll take a lot more pictures for you guys, some videos, and we can get some more detailed progress of where everything's at. So to reiterate, the chassis provides mounting for every system, well, every major system. Uh, the electrical system, they work around us, so we'll design the chassis, and then they'll figure out where to mount their stuff. Same thing with, kind of the same thing with ergo. It's like half and half. And then the aerodynamics people definitely work around us 100%. They're completely at our whim for whatever we want to make them do as far as shapes go. Obviously, the powertrain gets mounted in the back for, I want to say, 99% of Formula SAE cars. And then the ergonomics, we need to make enough room for a driver. The lower end is a 5th percentile female, which I believe is about 90, 95 pounds and 4'10". Abel, do you remember?
Never had to learn that shit.
It's basically a short chick that doesn't weigh anything. And then for a 6'2" guy, that's about 240 plus or minus. I don't remember.
So like Dio, it has
Yeah,
a
like
big
the
Dio inside of it.
95th percentile male. So there is a little bit of, I don't want to say adjustability per se, but there's definitely a whole lot of room to account for between a human that has a whole foot of variance in a SolidWorks model. Right, and most of that comes in like, oh, just bend your legs kind of a thing. Just how it works. But I think they made the pedals a little bit adjustable. I'm not sure. There needs to be enough room in the hip area for the shifter, because typically the shifter goes about your right thigh or your right knee, I want to say. So there needs to be a little bit of room for that. There needs to be room for you to get in and out of the car. There is a, I believe, a 5-second roll timer thing that the driver needs to be able to get out of the car from being fully buckled in 5 seconds. And they test for that, 100%. Boy, what are you eating over there?
I know this is like super stereotypical, but I'm eating Panda Express.
Hey man, Panda Express is delicious. Okay, that's not stereotypical.
Oh yeah.
Okay. As far as the dimensions of the car goes, there's usually about 3 or 4 different sizes of tubings we use, not counting square tubing. The roll bars right here behind the driver, and then the front hoop, main hoop, I think it's called, are made out of 0.95 wall or 95,000th of an inch thickness for the cylinder wall. And the rest of them are made from either 65 and I want to say 50 and 35. Although I think 35 is for optional tubing that you want to add in for various purposes. This is obviously not an SAE chassis. This is just some guy I know locally. But this is a Miata, and look, he just made a little frame around it, and it's pretty cool. Saving himself a few £100.
Might do that for the car I wrecked.
Yeah, that'll be very exciting. Okay, so as you know, the chassis is already done. Sad face. But that means we get more time to go over how we planned it, how we physically drew it up, how we ordered the material, how we assembled it, how we welded it, and then how we're going to process it later when we finally put some paint on it. Chassis purpose, we'll go over some of that some more. The basics of design. Ooh, that's what I forget to get a picture of. Okay. So I'm not sure if this is how they do it every year, but last year they set out with some goals for the car. We want it to be so long, so wide, use this type of suspension. So back in August, I want to say, maybe even before school started or right after school started, the suspension leader, Jimmy Salazar, got to work designing the suspension geometry for the car. And the mounting points of the suspension, not the actual, like, the outboard part of the suspension, but where it mounts to the chassis, dictates a lot of our design. So once he comes up with the design for that, then we can start actually physically modeling it in SolidWorks. We did run into a problem last time, however, where his front A arm, the lower one was like this, and the upper one was like this. I kid you not, there was about a 30, 40 degree angle on that suspension arm. Because the back was so low, it was literally about 4 inches away from the other suspension point. And that would not work with chassis rules. We figured that out in a few days, 1 or 2 days, I think, and got back to him, and he made some changes to his design that he deemed acceptable. I don't remember exactly what they were, but we ended up with the back A arm a lot straighter, a lot higher. And then we were able to continue with designing the chassis while he designed the rest of the suspension. SAE chassis rules. Can you guys make this out? I don't know how big your screens are, how detailed. Okay. So this is from the actual SAE rule book, which let me see if I can open that again. So this is a 2021. I actually just got this recently. I'm not going to tell you how recently. They published this on July 30th. Their goal was to make sure that they did not publish any rules that would disallow people from running their 2020 design car. However, they did state that they did change some rules. So we will go over this probably next session, maybe some of this session, but probably next session over the more specifics of it to make sure that we can run the same frame still. Because if for some reason we can't, and we don't catch it a year out, I'm gonna catch hell for that, and I'll probably be beaten up pretty severely. Right, Abel?
Oh yeah.
Okay, so over here on the left side, they have some general stuff, blah, 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 blah. Administrative documents. This will be probably for the team leads to go through and just make sure the formalities are taken care of. But I encourage everyone to go through this and see if there's anything that catches your eye that you might ask, hey, wait, can we do that? Have we done that? Are we allowed to do that? Do we need to do it? Stuff like that. It's good to just skim over the whole thing regardless of what team you're on. Obviously, our main thing will be under chassis and structural, which luckily is pretty close to the top. I don't know why it's F. It's weird. So it gives us some definitions. This is in the PowerPoint. Some other nice pictures here defining some of their terms. Obviously, most or all of these structural members need to be triangulated. That means they meet at a single point and not like this where the points are offset. This is a pain in the butt. This is basically a spreadsheet of every single chassis tube in the structure laid out and gone over with all of its specifications. And then there's one like this for the whole car, I believe. So that's always fun. But this usually, last year, this kind of got made at the same time as the manufacturing, since we already needed
Didn't we
an
already
entire
finish
list.
that?
Yes, it should be finished. Now, if we added anything little later on, I need to check over that, especially because I think they need to mess with the powertrain mounting a little bit. I heard some talk about that. So we'll see if we need to add anything. But this is already finished. But basically, when we had to prepare to order the actual metal, this was basically made at the same time from SolidWorks. There's a way in SolidWorks to just get a piece-by-piece list of all of your parts. So that's how we took care of that.
Hey, Josh, did Kyle ever tell you where we got our tubing from?
He did. I forgot the name.
Do we get it from the same place that we get it cut at?
I remember
Yes.
you had to pick it up.
We ordered it. I believe we ordered the 20-foot, 10-foot pieces from someplace, maybe another place. Maybe we had it left over. And then we took it to that company, and then they cut it based off the CAD. But I think they said next time we can just order it straight from them, and they'll cut it.
Oh, okay.
I'm not 100% sure on that.
No, I'll talk to Kyle about it, I guess.
Okay. Well, I'm just trying to make sure I don't have anybody else trying to get in here. Let me... Nope. All right, there's no waiting room. Okay, cool. Sorry. This is my first time being the master of the Zoom meeting. Usually I'm like you guys, like, oh, just click join. It's so easy. Okay, here you go. You guys see this right here?
Yeah.
Size A, size B, size C. So for the major members of the chassis, which most of the chassis is major members. We don't have a lot of extra unnecessary stuff on there. The sizings are pre-dictated. So ABC, this is the only one that's a D, but we do not have a bent upper side impact member, so we don't need to deal with this. This tells you if you have alternative material permitted, which we'll get into that in a second. But most of them are sizes A, B, and C, which is defined on this page. Their definition of it is the moment of inertia. So who here does not know what a moment of inertia is? Who here does know what a moment of inertia is?
I mean, I think I know.
Are you taking solids?
Yeah. Well, I'm taking solids right now.
Okay, so you'll know. Alfredo, do you know what a moment of inertia is?
Somewhat, but I would need a little refresher on that.
Okay, well, the non-mathematical term is basically the resistance to rotation, I guess. So I have here a surface pen, right? If I rotate it like this, it's still not that hard because it's a pencil, right? But it takes some time to go back and forth. But if I were to rotate it like this, it's a lot easier and has a lot less resistance, right? Because more of the mass is in line with the axis of rotation, right? So for the SAE equivalent, that basically is telling them like the cross-sectional mass area multiplied by its distance from the center. But luckily for us, we don't need to do most of those calculations because if we stick to round tubing size, if you see on the right column, they give us examples of what that means. But I just wanted you guys to understand the physics behind it. So like I said, we have 95, 65, and oh, it's not 50, it's 49. I was off by one. Right? That's the wall thickness. This is the tubing thickness. They're all 1 inches. Size D would be for that special bent impact member, but we don't have that, so we're good. It gives an example because you can have alternatives, although most people just stick with this because it's cheap and easy to work with. You know, all good stuff from manufacturing. There's some material strength down here, but if you stick to like the main steels, you'll be just fine. You know, don't go try to make it out of PVC because it's not going to work. Composites and materials. I'm trying to see if there's anything immediately relevant to us right now. Oh, some more rules. And we had, I don't know if we had a close call on this or if Dio was just taller than we intended. Were you there for that, Abel?
Well, oh yeah, I was there for the broomstick test.
Yeah. So let me.
I think Dio's just he's too big. He's too big.
He's a little big, yeah.
No homo.
I think he's a little taller than 6'2".
Yeah, maybe 6'3", 6'4". Maybe he grew a little bit. Maybe he has
He's
boots
always
on.
fucking wearing boots. Like doesn't help.
His ass is too fat, so it makes him taller on the.
He says he's like all torso or something. I'm like, okay. Sorry, I'm trying to load up the chassis from last year. It should be loading. Which we'll talk about SolidWorks, the program, in a minute. So this is the chassis as it sits designed in SolidWorks. And I don't think there was many changes from it. We did add some stuff right here for the headset, but that was more of an ergonomics thing than a chassis thing. Here is where the powertrain diff area gets mounted, and then there's some suspension arms coming off of here, and then I believe either up here or up here. I'm not sure. But luckily, Kyle, in his infinite wisdom, decided to color code it. So if you'll look, the 95 wall is the red. The other stuff is blue, and some of this other stuff is green, which was really helpful. And then that's extra stuff. Floor bracing, I forget if that was a major component. I don't think it is. But we decided to make it out of 35 wall, and then this is the square tubing. So for the front hoop and the back hoop, these two red hoops, I want you to imagine that there is a broomstick going from here to here, right? The top of this bar to the top of this bar. not the geometric top because it's off to the side a bit, but you know what I mean. The driver's helmet has to be 50 millimeters away from that. Converted into American units, that's just under 2 inches. It's like 1.9, 1.95 inches. We'll just call it 2 inches, right, and be safe. And they will test for that. I don't know if they use an actual broomstick, but they test for it. Also for this line, the helmet needs to be forward of the line between the top of the brace and the bottom of the brace. If you have a brace like this, like we do, the helmet needs to be forward of the top of the hoop and then whatever its extra bracing is. Also, they will insert a template like this into the car, right?
I think so.
We have one of these. I don't know
Person.
if we updated it, but we do have one of these. So we have here a hip equivalent, shoulder equivalent, and a head equivalent. Although this one's more of a helmet equivalent, I think. Neck, torso, and feet length. Important to note, if you design a chassis where the driver has to bend their feet to fit, and this will not work. The template does not bend its legs. And it has to fit in the car. I think this is that 95th percentile male thing. But yeah, this is fun. I made one of these in CAD, and it was a little bit more in depth than I thought it would be for a 3D working model, but it worked out just fine. Some rules for the hoops. We'll go over those a little bit more later. The steering wheel needs to be below, laterally, horizontally below the front roll hoop, which that's something for the ergo guys to keep in mind, although I'm sure they know. For bracing for the rear, you need to have plus or minus, or within plus or minus 30 degrees support for that. Don't forget the helmet. Most teams just have a brace going backwards because it gives them more helmet room. So they don't have to worry about the guy's head as much. Duncan should already know all this because he's a genius, right?
Far from it.
All right. This is the rule that we ran into last time. Let me make sure that this is. Oh, Kyle's here. Should be joining any second. Bro, I feel like some of those old teachers where they just like there's a notification in your face and you just don't see it. I don't know how long he's been waiting. I feel bad now.
Bro, just tell him you don't want him here.
You can take off the waiting room, right? You said I need to just do that. Hey, Kyle, can you hear me? I'm going to take that as a maybe. Okay.
He turned his mic off, but I didn't hear anything.
I think he's auto-muted, although I didn't mute him. I just leave it however. Anyways, remember when I said that we had the suspension last year? The back control arm piece was too low? We ran into that problem with this rule. So this side impact member needs to be within these dimensions between the front two hoops. And ours was too low last year, or at the beginning of that suspension design. So we said, hey, Jimmy, we got to lift this up or we can't make the chassis. So we lifted it and then we did this and we're within regulation. It's fine. But it's one of those things that like suspension wouldn't know to do. So we have to check that. Harness bar, support hoops. This is interesting. I think we took care of that. For critical fasteners, this is actually more ergonomic stuff right here for mounting the seat belts. Let's see. Oh, this is a little fun. Okay. So this, there needs to be a front plate in front of the front bulkhead. So this yellow piece right here, there needs to be a plate blocking that off. The reason for that, or one of the reasons for that, is that there needs to be an impact attenuator. Where is that? There we go. In front of that. What that basically is a giant piece of foam that absorbs the impact if you would crash into something. Like a truck, or a wall, or a light pole.
Or an excavator.
Right? Or anything that has that low of an impact height that you would see out in a parking lot. I guess other cars, that'd be interesting. Can you guys see this notification on my screen
Yeah.
from Zoom?
Yeah.
That's interesting. They're so sweet. Okay, cool. See anything else immediately relevant to us? By the way, if you guys don't already have it, like Abel said, I suggest downloading the Adobe software, which you can get directly from UTSA off of ASAP, because having the PDF program really helps. You can go through all the chapters. You can actually make and combine PDFs. It's really useful. Just get it.
Can you also make it read it to you?
Can you also make it what?
Read it to you. I think that was one of the options.
I don't know. You can try that later. I'm not going to do it now because I don't know if it's going to blast my ears or blast my speakers. Okay. So that's some of the basics of the rules of chassis. So what we went over, the front hoop, the main hoop, braces and supports, all of this good stuff. And then all of the gray members were extra. I kind of skipped over this. So a chassis in general is just a way of saying car support member or frame. This is a monocoque technically. This is also kind of that. But if you'll see, they molded some of the bodywork onto the actual frame itself, and it's made of stamped steel. Whereas this one's a bit more laid in woven carbon fiber shapes. They're still both frames. This design is technically called a space frame or a tube chassis. Depends how fancy you want to sound. Tube chassis sounds more redneck, and space frame sounds kind of like, oh, I work at NASA, right? Because there's space in between the chassis or the frame pieces. Does that make sense? Just somebody nod at me really, really obnoxious. There you go. I need to see like a head bob. Okay, so I'm going to introduce myself, and then I'm going to make you guys introduce yourself because I need to know who I'm dealing with, okay? So I'm Josh. I don't know if you knew that. Okay, I'm the SAE treasurer. I was a secretary, but now I'm the treasurer. There was an interesting thing there. I'm also the lead of chassis, obviously. What's my car experience? Well, a long time ago, I bought an RS8, and because it was a little bit less than reliable, I was forced to learn maintenance. Because after the first time of paying a shop to fix a problem, I was like, nah, I can't do this. Can't spend those $600 fixing my car every single time for a stinking fuel pump and some stuff. So I learned maintenance really fast. I went from spark plugs straight to dropping my transmission and change a clutch. So that was an eye-opening experience. After that, I had about $600 in tools because it was either 600-ish in tools or 600-ish in like labor. So I was like, oh, I'll pick the tools. You know, I can use them more than once. So I learned a lot of maintenance and theory off of that car. After I got it working right, I bought a Cobb to learn tuning on it. So I'm changing the air-fuel ratio tables, spark timing tables, some other accessories and engine responses when loads come on, such as like alternators, fans, lights, etc. I did get an automotive technology degree from St. Philip's, which is kind of like UTI, but like the poor version. Because, you know, I didn't pay like $25,000. I paid like $2,500, you know. And then my overall like career-long interest is building drop-in replacement space frames, which is kind of what these guys are doing. So this is actually based off of Miata, first-gen Miata. And this is a space frame they built to literally just drop onto the subframe mounting points and the suspension points, and you drop about 800 to 1,000 pounds off the car. But you can still use all of the same like turbo kits, wheels, suspension, brake systems. And I thought it was pretty cool. So I was like, oh, I can do that for other cars. So that's my long-term interest, and that's why I initially joined Chassis. So I'll make this a bit easier for you guys. Abel, tell me about your automotive-related background.
I don't know. My dad left me this third-gen Camaro in the garage. It never ran, so I was just tinkering with it. And got into cars.
Yeah. Okay. Is that the first Transformers movie one?
No, that's the second gen.
Oh, really?
The third gen is the one all those rednecks have. That's the
the mullet one.
the ones where the Trans Am version of it had like the pop-up headlights.
Okay.
It's the kit car, basically.
Okay, all right. I think I know what you're talking about. All right, Duncan, what's your automotive background, if any?
I don't really have much of an automotive background. I'm actually a civil engineer. I know most of the people in SAE are mechanicals, but I eventually want to be a structural engineer. So that's why I thought joining the chassis team would be really cool just to learn things. I'm into cars. I drive a truck that I basically abuse, but I'd like to learn more about cars.
Hey man, I kind of abused my truck too. It's got an engine that was 12,000 miles old when I got it, but the truck has like 190,000 on it. And I didn't change the oil for like 8 months after I bought it because I was a bad kid. It's still fine though.
I got like the front timing cover on mine replaced because it was like
Ooh.
oil really bad. Because I like took it like off roading, like my skid plate fell off and everything. I was like, okay, I need to.
Yeah, I think that's important.
To drive while I'm in school.
Right. All right, Antonia, what's your automotive background, experience, or interest? If you don't have experience, you tell me your interest.
No experience. But the reason I joined SAE was Jill introduced me to the club, and then because she's been sort of like helping me, I guess guiding me into looking for internships, and in the future I want to work with at Trek or at Cervelo. So these are bikes, and a lot of these require welding. So
Ooh,
yeah,
that's
I'd
interesting.
like to get some welding experience.
Yeah, and I think, well, no offense to bikes, but I think designing a bike frame would be a little bit simpler than a car frame, right?
Uh,
Maybe?
I think, I mean, but there's a lot more like material science to it. I get a little bit of welding, but more material science.
Okay, that's true. Yeah, a lot of automotive manufacturing materials have been pretty standardized over the years. We just have our basic groups of steels and aluminums and then carbon fiber when we want to get fancy. Alfredo, tell me about you.
So my name is Alfredo. You guys don't have to call me Alfredo. Y'all can call me whatever. I mean, I have a lot of nicknames. Just Fredo, Alfred, doesn't matter.
Okay.
Um, I don't have a lot of experience with cars, but I do know that I do want to go into the like automotive industry. So I would really like to work with cars. Um, my car does have a lot of problems, and I use it as well too. I mean, yeah, it has over like I think it has over already 200,000 miles. So I'd really like to learn about more cars.
Okay, cool. Yeah, I mean, definitely when we get more hands-on in the shop, hopefully soon, you know, you'll be able to see a lot of systems work together. Uh, Most of the car's pretty naked, so you can see all the systems without taking off any pieces or like getting under the car and going, oh, what's that, So it's definitely a good eye-opening experience. I mean, there's simplified systems, but they're still there. So I think it's really cool. Let's see, what else do I have for you guys today?
Can you guys hear me now? Should be
Yes.
All right. Well, I guess I'll introduce myself. I'm Kyle. So I was the chassis lead for the past 2 years. I actually joined SAE my very first semester, and now I'm graduating in December. So I'm like the last guy who's been around for all 4 years, basically. So I'll just be jumping in these meetings, giving advice. I'm going to help Josh with the design of the next chassis. And like when I joined, I didn't know how to weld. I didn't really have any experience working on like mechanical parts of cars and stuff. And you really don't need to know because you're going to learn as long as you're willing to put in the time. So SAE, like I know, Antonia, you talked about getting internships. I never would have got the internship that I got if I hadn't been a part of SAE. Like literally every interview question they asked me, I was able to answer with something that I got from being in this club. So it's definitely worth it. Yeah.
Sweet. So, yeah, I think actually I have an internship interview tomorrow, guys. And I'm pretty sure I got it because of my connection to SAE and my background experience working on my own car and tuning it because it was a little bit unreliable, but I guess that paid off because, knowledge and stuff. So yeah, I mean, hopefully you get a lot from this. It's definitely good for your resume. It's good for your personal experience. It's good for team building because outside of high school, after college, I mean, if you're not into sports, there's not really a whole lot of teamwork you're forced into besides like maybe lab groups. Although even this semester, all of my lab groups have turned into single lab reports for just me. Like I'm doing my own lab report and it's a little lame. So this is definitely a way to actually get ahead of some of your other college peeps. Get some teamwork, get used to it, get used to a design process, a structure, learning how you fit in at different levels, learning how to give feedback, especially both immediate and then over the years. So I think this is a good opportunity, and I think it's probably the best club UTSA has,
Yeah,
but I'm
definitely.
biased.
When you graduate, like think of it, you're gonna have a piece of paper, and so are hundreds of other people, and what's gonna, set you apart from those other people? Definitely SAE. It's the number one thing. Like companies are big on looking for SAE on a resume, so definitely stick with it, and it'll pay off.
Hey Kyle, is there anything else you wanted to add about like an introductory chassis information that I missed?
No, I think we're good. I know I missed the first like 20 minutes, but
No, it's good. I didn't know how long you were sitting in the waiting room because I felt like
yeah, I'm in class right now. It's really boring. So
yeah, I feel bad for you. Were you the one that couldn't make it like on that vote?
yeah, probably.
Oh, okay. Well, I'm gonna try to record all these and then I'll upload them and we
Yeah,
can
it's
go
all
from
good.
there.
I'll probably be on time for the rest of them because this class is kind of dumb. So, yeah, I'll be helping. I know you were explaining the rules and stuff, and I'm sure you explained the front roll hoop and like the problems we were having with that. But rules are huge for chassis, and there's a lot of little things that you have to be careful for. So I'm going to help Josh and help whoever else wants to be involved with the next design. But it's a lot of fun. You'll learn how to do it in SolidWorks. It's way easier than you think it would be. So don't worry.
Yeah, Kyle actually has a good reputation of making it easier than other people do. I remember how to do it conceptually, but it's a while since I've put like my hands like on SolidWorks and done it. So I'll definitely have to practice before I bring that to you guys again. And maybe I'll have Kyle show you a little bit on that too. We will learn how to test for structural integrity in SolidWorks, which I think is really useful. It's also a good way to waste time because it's funny. It'll actually show you the materials physically bending to the forces you put on them. So it's just a fun way to test out whatever you want to put in there. And of course, you can change the materials and the thicknesses of them and everything in there. So you can actually make it made of wood or styrofoam if you wanted to, and just see what like, I don't know, 1,000 kilograms does to wood when it's, or sorry, 1,000 newtons or engineers and newtons. All right. Let me just go over some of the basic manufacturing parts of this, and then I'll let y'all go for now. Sorry, this meeting's probably going to be a little shorter than you wanted. I've been super busy this week with 2 tests and then the little internship thing, but let me go ahead and share my screen. All right, can you guys see my SolidWorks model again?
Yes.
Okay, so we'll go over how to use SolidWorks a little bit more later and how to get it. There's quite a few ways to get it. So don't worry if you don't have like $1,000 a year. We can get around that. Okay, so how it usually starts is, what did I want? Oh no, that one. So how it usually starts, we get the pieces back from usually whoever who did we get them from, Kyle? Who cut them for us? No, he's silent, okay. So anyways, each one of these little tubings that's here is actually an individual part or can be made into an individual part in SolidWorks. So we sent them out, they get cut. The only rules for that is that these bars, these roll hoops, have to be one continuous piece. And there are like CNC perfect ways of bending them. We did not do that last semester. I think it would have cost a little bit too much or we didn't have the right connections. Maybe we'll get around that one day. But basically you have to bend these into precise shapes in precise locations in one contiguous piece. Once that's done, ton of a butt. I pressed F4 instead of 4. That was my bad. Once that's done, the roll hoops will be physically welded onto the table. That's how we construct ours. There's other ways to do it, but it's worked for us for years and years. We have a large flat steel table that we will weld these onto very precisely. We will measure everything probably about 8 times before we let it sit, and then measure it like 2 or 4 more times before we start adding too many pieces on there. For this, obviously, they're both straight up. Some cars that's changed. For this, it works just fine, so we kept it that way. It's easier to manufacture. And then from all of these pieces that we get from the metal people, which we have about 3 or 4 metal partners that we work with, we can start sliding them in exactly where we want. I think the first 2 that we would probably do, would be this long piece right here. It seems the easiest to start with. It is actually notched like this, so it has the kind of curve cut to it, so it'll fit exactly where we need it to. Start with the long pieces, then we have these that we shove in there. We'll tack weld everything in place. Nothing gets full welded until just about everything is tack welded in place.
The introductions from the shop floor.
You had something you want to say, Kyle?
I think in our introductions chapters, I already talked about this. It's basically the thinkings from the
Okay, your microphone's on, just FYI. Where's the chat on here? Jeez. Okay. Sorry, guys. I'm new to being a Zoom host. Okay, if you can't tell. Okay, so like I said, these get welded on. We'll put these tubes into place. This one was actually really fun. I personally measured this probably about 20 times on each side to make sure it was right, because this piece is not, I guess, in line with any axis. It is not straight. Let me make sure I don't do this wrong. It's not flat. And it actually comes in a little bit, which is really hard to see right there. So I had to precisely measure the point of this tube, which I had to pick a point, you know, the center, the top, or the outside. And I precisely measured where to place that in space, held it there with my hands while somebody welded it, and then welded these pieces in. And then we measured it again and again and again. Because the suspension point very critically depended on the location of this node, which a node is just where all the tubes meet. This one was obviously easier. This one's stupid easy. This one's easy. This one, like I said, required a lot of precision. So this was done completely by hand. Maybe in the future we can figure out a way to just 3D print a jig that will put this in a precise location. But last time I literally just held it there with my hands while somebody welded it. After most of the tubes are put in, it becomes a lot easier. This was relatively easy. We also welded this to the table, which was fun. It's all fun. And once we get them all together, we measure everything a couple more times. Everything gets full welded in as far as it can from the top. And then the chassis literally gets jerked and broken off of the steel table and comes off in one piece. And that's how the chassis is made. That can happen in as little as 2 to 4 days. And we did it over Christmas break, I want to say. Christmas break or sometime in early January last time. Hello.
You hear me?
Yeah, what's up?
Oh, that's weird. Anyways, yeah, I didn't mean to interrupt you. You can continue.
Oh, okay. So fun point, you might be asking, why is this one all square and ugly? This was for the push rod mounting for the shocks. I don't know if this would normally be square. I guess it just depends on what the ergo and brake guys want to put in here. But like I said, that's one of those design things that's just kind of collaborated on. Again, power train guys give us the specifications for these. And by specifications, I mean 2 tubes and a round mounting point. Wasn't that complicated, but we still had to work it in there somehow. And the rear suspension design dictated this, although I was not involved in that as much. I need to figure out more of that. Does anybody have any questions over this? Duncan, do you have any questions?
No, no,
Okay.
sir.
Explain a little bit about how it used to be done, if you want.
Yeah, sure. Because I was only there for that last year.
Yeah, so basically the 2019 car that is currently unfinished, and then the car before that, both of those chassis, we basically bought all of the tubes in 20-foot lengths. So we just got like 200 feet of tubing in 20-foot pieces, sent it off to the company, and then it was like CNC laser cut. So every tube was notched perfectly like it is in the model, and then just put on a pallet and sent back to us, and we literally were able to put it together like a puzzle. So before we started doing that, we used to make every single tube by hand with a chop saw and a tube notcher and like angle finders, which it saves you a lot of money, but it also takes about a month longer. So laser cutting has saved us a ton of time these past 2 years. We're probably going to do it again for the next frame. And then we do bend the roll hoops ourselves. It's very tricky to get right, so good learning experience bending the front and rear roll hoops. And then there's a couple changes that Josh and I have talked about that we know we want to make for next year. But basically, the goal of this chassis is just to be as light as possible while being as stiff as possible. So while meeting rules. So this chassis is kind of unique because we are, I think, either the only team or one of two teams that runs the type of rear suspension that we have. So the back of our chassis is really, you don't see it on any other cars. So it's really simple, and we're just trying to continuously improve. But yeah, whoever's interested in helping design, just keep coming to these meetings.
Yeah,
Hey, Kyle,
something.
where
Oh,
do
go
we
ahead.
get the tubing? Where do we buy that from?
So we buy it from Westbrook Metals. They're like 30 minutes away.
Oh yeah.
Of course, a discount. So they've been my go-to shop for 4 years now. So
And then we get it notched at what was it? River City Industries.
Yeah, River City Industries is the company that laser cuts everything. They have crazy machinery. Their laser cutter can take like 40 feet of tubing at once, like 9-inch pipe. So it's pretty easy for them. They can knock it out in a day. And like Josh said, it only takes about a week to build the chassis and just have it tack welded together. Fully welding it takes quite a while. You have to go around every single tube end all the way. So it takes a while, but honestly, I think building the chassis is one of the funnest parts of the car because you actually get to see it start coming together. So, yeah.
Yeah, I definitely liked it. We had long days because really nobody wanted to leave. They just wanted to continue progress on this. But obviously, even though everything's notched and laser cut, it's still not perfectly easy because we do need to measure everything.
Yeah, so there'll be, like we actually made a mistake last year, and a couple of the tubes
Oh yeah.
that are on each side, they were made exactly the same instead of being mirrored. So we had to cut and notch a few by hand, which I kind of like when stuff like that happens because you get to learn how to use the notcher and make stuff fit right. So don't worry about, not being able to do something. You'll definitely learn how to notch and bend and weld and all that stuff. So.
Yeah, I think it was these two hoops in particular
Yeah.
where we had two of them like we needed, but instead of having a left and a right side, we had two lefts or two rights. And we didn't figure that out until assembly. So I had to notch both of these, and it's interesting because you don't want to leave a huge gap for welding, but obviously, I guess the tighter you want this tolerance to be by hand, the more times you have to check. So this first one, I made a cut, and then I sanded it and cut it, notched it probably about 10 more times. And then the other one I did probably in 5 or 6 times. But that was another example of literally doing it by hand 100%. And the old tube we just had to throw out or use for welding practice or whatever. Anything else you wanted to add, Cal?
I guess one more thing. So you might have already mentioned this, but basically, you can't design the chassis until you have the front suspension figured out, because it all starts with the front roll hoop and where the front suspension pickup points are. So basically, the lower bend on the front roll hoop dictates really how the rest of the chassis comes together as far as the front and the middle. So there's a lot of rules about how that suspension point has to be mounted. So it's just one of those things that we struggled with last year. That's why there's that crazy notch tube right there. That was added because of how low that bend is, and it's not necessary, but that was the only solution. So we're gonna try
Yeah.
and avoid stuff like that, this time. We're also gonna make the front bulkhead smaller. It's way too big. We were just playing it safe, so we know what we can save some weight there and get rid of that diagonal and see what else. So yeah, little stuff.
Yeah, I think the diagonal is only necessary if you're beyond a certain size.
Yeah.
If you're beyond, I don't know if it's 13 by 13 or 14 by 14, something like that. But we can make this smaller. I think Kyle told me by an inch in height and an inch in width.
Right now it's 16 by 17. We can have it either 15 by 16 or 14 by 15 is like the lower limit of what I would want to do.
Yeah, and we'd have to.
Careful, with the template.
What was that?
You just have to be really careful with the templates that they test.
That's true. That's another thing. Something I didn't see in the rules as far as pictures go. There is a template that gets passed through the front roll hoop and has to go, I think, all the way to the pedals or all the way to the front bulkhead. I forget. But it needs to pass all the way through here without hitting anything, including your steering column. Or I think it kind of goes around it. I feel like someone's trying to say something, but I just keep hearing an echo. No? Okay. Something I definitely want to collaborate on suspension with is where, let's get a good view. So Jimmy really had it set in his head that he wanted this back down here. Obviously that didn't work for us. So he came up with this, which was still a little bit too low for us, but we could make that work with another diagonal, which is what this was. Hopefully we can get in touch with whoever's designing suspension for 22.
So Jimmy, I had to work with Jimmy, and we probably revised this setup like at least 5 or 6 times. We had to redo this. So basically the rule states that, well, there is a rule that the bottom blue tube of the center section that you see, that bottom tube, the distance from that, or the bottom flat one.
Oh, okay, so there's a node.
The distance from that to the top flat blue tube of the middle section, yeah, that one. So there has to be at least, I forget what the exact number is. It's like, I don't know, 13 inches in between those.
This, yeah.
And so that bend on the front roll hoop cannot be more than 2 inches away from that top blue bar. And in this model, it's like just barely over 2 inches, which is why we added that extra tube in there that goes directly to it. And it's still technically kind of violates the rules, but the guy that does the like tech submission document said he would allow it. So we're just gonna try and avoid that whole headache for the next one.
Yeah, but hopefully we can collaborate with suspension and just get rid of this entirely and have the suspension in line with this. I think this could maybe be a 1/2 inch lower or maybe 1 inch lower. I'm not sure. Actually, no, it's probably as close as it can be. If we can get suspension to come closer to this, it saves us a lot of reiterating in the future and would make the car more lightweight because we can get rid of this on both sides. Which I think the chassis, how much does the chassis weigh, Kyle?
I think this one weighs like 54 pounds, which, like, if you can get a 50-pound, you rarely see sub 50-pound chassis. 57 is like outrageously heavy, and then you really want to be like 50, 51. That's best case.
Yeah, so we might be able to do some more optimizing, especially here and here. Maybe some more here. We'll see what the axle setup will be next year, depending on how much redesigning suspension wants to put in. Because we basically have what's a live axle, so suspension on one movement affects the other, kind of. Although we do have independent axles. I need to look more at the geometry and see how that works out. But yeah, that's all I really have for today for you guys. I hope that was a good enough first day. If you guys have any questions on stuff you want to know, either this session or next section, just let me know. And I will do my due diligence in doing extra research on it, okay? Because I've been busy this week, but Saturday and Sunday, I'm like 80% free. So I got lots of time to just look up whatever. Any questions or comments? Nobody?
I just want to add, there's a book on welding that I think Jimmy was gonna link on. I sat on his meeting. He said that there's this book specifically on welding. I'll be able to get that. I'll probably put it in your chat if you want to.
Yeah, is that in the officer Google Drive already?
Possibly.
Did you? I looked around in the drive just earlier, and there was a whole a collection of 20 books or so,
It's
like
possibly,
automotive related.
yeah, I
books.
think it's probably in there. I just haven't like access to the drive yet.
Okay, cool. The next session, I think we'll go over drawing with SolidWorks more, a little bit more in depth on some of the chassis rules, like the specifics, and what else? What else? And I'll figure out something else to add on there too. Maybe some structural integrity stuff. But I'd rather you guys get hands-on with that. So Duncan, Antonia, and Alfredo, do you guys have access to SolidWorks?
No.
No? Okay.
Yeah, I do. I have the app. I know that there's a student license on UTSA.
Yeah. So I know a few ways to get it. SAE has some licenses, but we like to hold on to those until later in the year when people are actually, they've proven their dedication and they're going to do some work on it. We don't just hand them out for free, but we do hand them out eventually. There is a way to go to SolidWorks on your own and enter like your own like UTSA email, and you'll get it that way. And then I know the drawing class for UTSA gives out a license for it too. But you said there's a way to get it through UTSA.
Well, it's because right now I'm taking graphics and design.
Oh,
with
okay.
Yeah, that's the class that
Rao.
gives it to you.
Yeah, so I have the student license right now.
Okay, yeah, I used that last year and it was good for, I don't want to say an infinite number of copies, but I used it. Some of my friends used it. It wasn't even my class. So Duncan, do you have it?
I don't.
No? Okay, I'll try to figure out what the best way to get it to you is. Although I think it'd be easier for you guys if you just went to the SolidWorks website and try to get it. I'll try to poke around in there from my end and see what procedure you need to do it. You don't need.
Honestly, the best way to get it is, I know you mentioned it, but we get like 35 licenses a year from SolidWorks to just give out to our team members. And usually, like, we prefer if you were on the team for, a semester or some amount of time, so we know you're going to stick around before we give away a license. But we can give out licenses for free, and you can just download it on your computer. Super easy. And it's good for, like, each license is good for, like, a year and a half, I think. So that's what we're going to do, I think. We still have a ton left over from last year. So.
Okay, yeah, I think we still have some that are good through next summer from last year. Like mine should have expired already, I guess, because I thought it was good for a year, and I got it about a year ago. But I guess it's good for a year and a half. So we'll see. You don't need a super powerful computer to run basic levels of SolidWorks like this. When you get into full assemblies with 100 parts and some of them move, you'll start seeing problems. But for drawings and basic, like, metal frames like this, you don't need a beefy computer. Although I'll let you know that you can, no matter where you are, you can access it remotely off of UTSA. I'll tell you right now, it's a pain in the butt because everything you do lags a little bit. Every single button you press lags for at least a half second or full second, which doesn't sound that bad. But when you're doing like 100 inches, 100, enter, every single button lags, and it's annoying.
Oh
So,
yeah, dude.
that's
I have
why
an intern computer at work, and they have me doing stuff with like, hundreds of layers on AutoCAD, and then like everything lags. Like if I press Control Z, it takes like 10 seconds to like reload it.
I know it's a pain, but so it's just so much better to have like a local installation of it on your own computer. But if you're just drawing stuff, you can always do it remotely, and it's not that bad. But if you get a little heavier, it becomes really annoying. Okay, that's all I have for today, guys.